No factory, no warehouse, just a desk at home, running a real manufacturing line. Sounds impossible? In this video, I'll show you exactly how a full product is built, assembled, and shipped from a home setup. The product is called the Micro Racer, a tiny, open-source racing car that reacts to obstacles and boosts, making it a fun, interactive kit. Now let's explore the production process. Step 1. PCB assembly. The first part of the setup involves the electronics. A pick-and-place machine handles most components, but assembling PCBs remains time-consuming. Some components require hand soldering. Some need adjustment, followed by cleaning and testing. Testing uses a custom jig with pogo pins to ensure motors spin and sensors function properly. This basic setup allows the process to improve over time, with automation planned for the future. Any PCB that fails testing is marked and set aside. Close attention to procedures ensures the system can scale efficiently. But here's the catch. While the electronics are coming together nicely, what happens when you need hundreds of tiny plastic parts to match that precision? Could the tools we use for one part of production handle the sheer volume needed for the next? That's exactly the challenge the team faced in the next stage. Step 2. Manufacturing parts. Next are the physical parts. 3D printing is used for the plastic components. Printing a single part is straightforward, but producing hundreds presents a greater challenge. Before upgrading the printer, multiple iterations were tested to achieve consistent quality. With a high-quality printer, parts now have professional-looking finishes, and the first layer is perfect. Important because it faces the customer. Small improvements like this have a significant impact. Even with perfectly printed parts, there's still a bigger hurdle. How do you keep track of all these tiny pieces and make sure every kit is ready on time? That's where workflow organization becomes crucial, and it's a step that can make or break small-scale production. Step 3. Organizing the workflow. Once all parts are ready, work is organized into focused blocks of time. One day dedicated to PCB assembly. Another day for 3D printing and producing parts. Another day for kitting and packaging. Concentrating on one task at a time keeps the process manageable, even in a home environment. Living in a house filled with production materials presents challenges, with boxes and kits occupying multiple rooms, but careful organization keeps production moving smoothly. Support from family is a key factor in maintaining productivity, so everything is prepared. But there's one last challenge looming. How do you assemble and ship dozens, or even hundreds of kits without mixing up parts or making costly mistakes? That's exactly what the final assembly stage tackles. Step 4. Final assembly and packaging. After all components are produced, kits are assembled. Fulfillment presents additional complexity, with customers ordering varying quantities and international shipments requiring manuals in specific languages. Boxes are carefully packed with the correct materials, labels, and documents before shipping. Detailed planning, repeatable steps, and clear procedures ensure efficiency and scalability in the production workflow. And that's the journey of the Micro Racer. From tiny PCBs and 3D printed parts to fully assembled kits ready to ship. Every step shows how careful planning and small improvements can make a big difference in production. If you want to keep exploring, click the video on your screen now. I will see you there. Bye-bye.